This is PreCalculus, Functions and Graphs. I'm Mr. Stark. We're on topic 3 of this unit, but this is the 7th lesson, which is titled 12 Basic Functions. And guess what? We'll be looking at 12 basic functions. But not just looking, we'll be analyzing the graphs and making a note of the properties that we learned in topic 2. You can follow along using these 2 documents. Let's check out the graphs. The first one is the identity function. It's fairly basic. The domain is all reals. The range is all reals. It's unbounded, continuous, and it's an odd function because it's symmetric about the origin. We can see that symmetry in 2 ways. We can reflect the first quadrant over the x-axis, then over the y-axis, or we could rotate quadrant 1 180 degrees. Here's the absolute value function. The domain is all reals. You could plug in any x value, but the range is 0, infinity. It's inclusive of 0 because the absolute value of 0 is 0. The absolute value function is continuous, bounded below, and has y-axis symmetry. So it's an even function. We can see that symmetry by reflecting quadrant 1 over the y-axis. The squaring function is defined by f of x equals x squared. Remember, this is an even function. Its domain is all reals, and the range is the same as the absolute value function, 0, infinity. It's continuous, bounded below, and like I said, it has y-axis symmetry, or it's even. The square root function is f of x equals the square root of x, or x raised to the 1/2 power. You can see this as the top half of a sideways parabola. The domain and the range are the same, 0, infinity, inclusive of 0. It's continuous, bounded below, and does not have symmetry. If we drew the bottom half of the parabola, it would have x-axis symmetry, but then it wouldn't be a function. The cubing function is f of x equals x cubed. It's a smooth, continuous curve with domain and range of all reals. The curve is unbounded and is symmetric about the origin, so it's odd. One unique thing about the cubing function is that it's always increasing. The reciprocal function is 1 over x, and it's a pretty common function to use in science. The domain is negative infinity, 0, union 0, infinity. And the range is the same as the domain. This function is actually continuous on its domain, but it's discontinuous at x equals 0. We don't need to get all riled up about this, but because x equals 0 is not part of its domain, we call this function continuous. It's unbounded and symmetric about the origin. So it's an odd function. One unique thing about the reciprocal function is that it's actually always decreasing. Check it out. When you start from left to right, it decreases, but then it jumps to the top, and then it keeps decreasing. On the other hand, the exponential function e to the x is always increasing. The domain is all reals, and the range is 0, infinity, exclusive of 0. E to the x can never be equal to 0, no matter what you plug in for x. The function e to the x is continuous, bounded below, but doesn't have any symmetry. It's usually used to represent population growth. The natural logarithm function, or ln(x), is the inverse of e to the x. The domain of this function is the range of e to the x, 0, infinity, exclusive of 0. And the range of ln(x) is the same as the domain of e to the x, which is all reals, negative infinity, infinity. The natural log function is continuous, and even though it looks like it's bounded above, it's unbounded. As x approaches infinity, the natural log function grows slower and slower and slower. And speaking of its growth, it grows a lot at first, but then it levels off. But this function is always increasing. One last thing, it has a vertical asymptote at x equals 0. The sine function, not sin, is a trigonometric function that models periodic behavior. The domain is all reals, and the range is -1, 1, inclusive of both of those values. The sine function is a continuous function. It's bounded, so it's bounded above and below, and it has origin symmetry. It's a little hard to see that, but again, if you reflect the curve in the first quadrant over the x-axis, then reflect it over the y-axis, you'll see. The cosine function is very similar to the sine function. It's actually just transformed to the left or right. The domain is the same, all reals. The range is the same, -1, 1, inclusive of those values. It's continuous, bounded, above and below, and has symmetry. Except the cosine function is even, so it's symmetric about the y-axis. And you could see this a little more clearly versus the sine curve. Okay, those are the 10 most common functions. We have 2 more, and they're quite unique. This is the greatest integer function, otherwise known as the step function. The int notation is more common than the bracket notation, and this function can be found on the TI-84 calculator by pressing Math, arrow right to num, and it's the 5th option. The domain of this function is all reals, but the domain of this function is all integers. Since this function has a domain of all reals, it's not a continuous function. And it's somewhat difficult to define the boundedness of the function, but I would say that it's unbounded, because the larger the x values that you plug in, the larger the y values that you'll get. Finally, it's very close to being symmetric about the origin, but officially it's not. To see why it's not, consider that segment between 1 and 2 that's at the y value of 1. If you reflect that over the x-axis, then reflect it over the y-axis, it won't match up with the rest of the function in quadrant 3. The last thing I'll say about this function is that it's used to model discrete values for situations, meaning like a parking garage, where for the first 2 hours you get charged a certain amount, and then the next 2 hours you get charged a different amount, or for packages or mail. And the other unique function is the logistic function. F of x equals 1 divided by 1 plus e to the negative x. Kind of tricky. One unique thing about this function is that it has 2 horizontal asymptotes. One is y equals 0 and one is y equals 1. This function can model population growth that's limited. Check it out. First, the curve increases, kind of like the exponential function, and then it starts to level off. The domain is all reals. The range is 0 to 1, exclusive of both values. It's a continuous function, bounded above and below, but has no symmetry. If it went through the origin, it would have symmetry, but it doesn't. That's it. Those are the 12 basic functions. While analyzing graphs could be somewhat dry, for lack of a better word, it's important for us to train our brains to notice details like the ones we just looked at. Because in mathematics and everyday life, there are a lot of details, and we want to make sure that we notice them. Like Ferris Bueller said in 1986, life moves pretty fast. If you don't stop and look around once in a while, you can miss it.